Welcome! Have you heard about the solar polar vortex? If not, you soon will do. It seems to be joining the other sets of pseudoscience associated with the sun, that the sun is causing global warming, that the sun is going to micronova any second now and boil us all to death, or it's going to crash into a grand solar minimum and we're going to freeze to death. Hopefully those last two will happen at the same time and we won't notice the difference. But no, the latest thing is a solar polar vortex. And there's a picture of it here at the bottom of the slide. Unimpressive, don't you think? I'm going to explain that this is a perfectly normal phenomenon that's happened many, many times before, and people are just making this as a load of hype. Well, let's take a look at some of the sensationalist headlines. Part of the sun breaks free and forms a strange vortex, baffling scientists. A strange, unprecedented vortex spotted around the sun's north pole has scientists really excited. A massive filament swirls into a vortex on the sun, wowing scientists. First time such a phenomenon has been seen on the sun. The sun is kind of broke. It's doing something weird and scientists have no idea why. Enormous polar vortex on the sun is unprecedented, scientists say. This filament snap forming a polar vortex that scientists can't explain. Well, I'm not particularly baffled by this. I'm not excited by it. I'm particularly not wowed by it. I do have lots of ideas of why this occurred. The real purpose of this video is to point out all of this stuff is just hype. And I'm sad to say that some serious space weather presenters on YouTube are jumping on the bandwagon. And I think it undermines their overall credibility. This is what they're getting so excited about. It's certainly a large filament near the north pole of the sun, but I don't see anything particularly special here. And let's take a look at the video taken over the last few days, which got everybody so excited in the first place. We're going to use the AIA instrument helium-2304 channel to look at this filament. It starts off with one part of the filament trying to rise up, and then it starts reacting with the western part of the same structure. Then it reaches back to the east until the whole of the polar area is involved in this structure, and then it lifts off. To understand what's going on at the North Pole, we should really understand the situation first. We are seeing a perfectly common phenomenon, the eruption of a filament. These happen all the time, many times a day. However, this one is in an unusual place, the North Pole. We don't get many eruptions there. We do get some, because generally there isn't very much activity going on there to cause the filaments to erupt. It's a nice, safe and quiet place for them. We're also seeing it at an unusual angle. The tilt of the sun's rotation axis is away from us in the northern hemisphere at the moment, so we're seeing this filament edge on for the first time for a long time. And it's at an unusual time. We're in the rise phase of the solar cycle. As the polar coronal hole shrinks, that filament gets nearer and nearer to the limb of the sun. So why is this phenomenon happening now? First, we need to understand the situation. The sun is about 3 years into its latest solar cycle, so number 25. You can see a picture of the sunspot numbers over here on the right, and you can see we're well up the rise phase of that cycle. In fact, last month was a record number of sunspots for this cycle. So the sun is very active at the moment, unusually so. And as I said, the tilt of the sun's axis is negative. That means that the North Pole is tilted away from us, as shown in the figure here. And that leads to the sun breaking up into 4 magnetic zones. Let me explain what those are. Here's a picture of this magnetic sun, taken with the HDO HMI instruments magnetogram channel. At this stage of the solar cycle, the 2 polar regions have opposite magnetic polarity. At the moment, the northern hemisphere is positive and the southern hemisphere is predominantly negative, shown here by red and blue respectively. When that happens, you get a large dipole field. So this is the dipolar sun that you hear so much about. And it's this large-scale field that stretches throughout the solar system and immerses the Earth in its wake. But at the same time, we have the 2 hemispheres of the sun at opposite polarities. At the moment, we have the northern hemisphere predominantly negative, and the southern hemisphere, again, except for the polar regions, predominantly positive. So this is now what's called a quadrupole sun, because we have 4 different layers of magnetic field. The North Pole is positive, the Northern Hemisphere is predominantly negative, the Southern Hemisphere is predominantly positive, and the Southern Polar region is predominantly negative. When you have this structure, you have other magnetic connections building up across these divides. So there's a neutral line set up at the 2 polar regions. And neutral lines are where filaments and prominences form. We can see that if we look at the Sun in H alpha. Here's an image taken in 1999 in H alpha showing the filaments and prominences very clearly. The prominences are the bright things on the limb, the filaments are the dark things on the disk. You can see at both polar regions shown here with the blue lines that we have polar crown filaments, filaments surrounding the polar regions, particularly there in the southern region. It's prominent. We can see that structure on the Sun today. Here's a picture taken by the AIA instrument on SDO. And if you look at the southern polar region, you can see a dark line between those 2 blue arrows. That's the polar crown filament. You can't see it so clearly in the northern hemisphere because it is just lifted off. But you can see where it should be because there's these gaps in the magnetic field. And that's where the division between the 2 polarities lie. The thing about filaments and prominences is they erupt all the time. If you go over to my Twitter channel, you'll see almost daily examples of same. In fact, every time a CME erupts, a filament is generally involved. And we're averaging at the moment between 5 and 10 of those a day. Let's show you some examples. Now imagine that this picture was turned on its side and that was looking at the North Pole. Doesn't this look spookily familiar with the structure you just saw lift off of the North Pole? Here is a second similar event, but this time it's on the northeast limb rather than the southeast limb. But again, it looks very similar to what we are seeing around the North Pole. So this is just a common prominence erupting away from the Sun. But how often does the polar crown filament erupt? Well, it has happened before. Here is a picture taken in 1999 of the southern polar crown filament erupting actually quite violently in this particular case. This one is much more spectacular than what we saw in the northern hemisphere earlier this month. I'm going to show you a movie of the last 3 months of the polar crown filament in the north and its evolution. And you'll see that this sort of eruption has happened several times before. Well, you can see from this short example of the evolution of the polar crown filament that it has tried to lift off several times in the last 3 months. Well, a coronal mass ejection is in fact a large mass being thrown away from the Sun. So from that point of view, a large body of matter did break away from the Sun. But we get anything at solar minimum like 1 of these a day to now up to 20 per day. So this is nothing any particularly usual. The mass of a coronal mass ejection can be as high as 10 to the 17 grams or about 10 to the 11 tons. And that's, to give you some idea, is 1 million aircraft carriers traveling at about 10 million miles per hour. But if you're concerned that the Sun is losing too much mass, that is 0.000000000000001 1% of the mass of the sun. So the sun could be doing this for trillions of years and wouldn't really be affected by the loss of mass from coronal mass ejections. So what conclusions can we draw from all of this? There was no solar polar vortex. I see no vortex forming, but it's certainly not an unusual situation. It was the simple eruption of the northern polar crown filament. We're seeing it from an unusual angle at a unique time in the solar cycle. It's happened many, many times before. Every time a filament or prominence erupts, a large amount of solar plasma is thrown out into space. Again, nothing unusual and nothing to worry about. So if you hear anybody pushing this idea of a solar polar vortex, pay them little or no heed at all. They're just trying to hype up this whole situation to get more clicks on YouTube or to frighten more people. It's just a bit more fear porn for everybody to worry about. So this is nothing unusual. Just keep watching what the sun does. So thank you for watching. Stay safe. Until next time, goodbye.